Concavity and the second derivative test. Derivatives can tell us a lot of information about the original function. Next, we will discover what information the second derivative provides about the original function. Recall that the sign of the first derivative told us whether the function was increasing or decreasing. The sign of the second derivative will tell us where the function is concave up or concave down. Concave up, these two here, look like a cup. Concave down looks like a frown. So here we have concave up but decreasing, concave up increasing, concave down decreasing, and concave down increasing. Some functions remain concave up or down for all x in their domain, but many others can change concavity at multiple points. For example, label each section with the correct concavity. Here the red sections are concave up, here and here, and the blue sections are concave down. An inflection point, or point of inflection, occurs at x equals c if a function is continuous at that point and the function changes concavity. Note each star represents an inflection point for the function above. So here we have a continuous function, but right here it changes from concave up to concave down, so here is our point of inflection. Since we are able to graphically interpret concavity, now we will discover how to algebraically determine concavity and points of inflection. The first step in finding intervals of concavity algebraically is to find critical values for the second derivative. These critical values will occur when the second derivative equals 0 or is undefined. The sign of the second derivative determines the concavity of the original function. If the second derivative of f of x is greater than 0 for on an interval I, then f of x is concave up on that interval. If the second derivative of f of x is less than 0 for on an interval I, then f of x is concave down on that interval. If the second derivative of f of x has a critical value, where it equals 0, at x equals c, and changes signs at x equals c, then x equals c is a point of inflection. Find the critical values for the second derivative using the following function. Here's our original function, so we just find the first derivative and then the second derivative here, and then we find where this equals 0. So because the second derivative is defined for all x, we just have to set it equal to 0, and we see that if we do that and solve, we get x equals 2. So our critical value is x equals 2. Find the intervals of concavity as well as any points of inflection. So we have our original function and we have our second derivative. On the previous slide, we found the critical value to be x equals 2. A sign chart for the second derivative tells us the intervals of concavity. So f of x is concave down on negative infinity to 2, and it's concave up on 2 to positive infinity. F of x has a point of inflection at x equals 2 because the sign of the second derivative changes at this point. Note, the second derivative test does not replace the first derivative test. Both are useful tools. In fact, at times, the second derivative test isn't necessary. Using the first derivative test, we can conclude intervals where the function increases and decreases. If the function changes from increasing to decreasing, the concavity there is down and vice versa.